Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, the 2013 question 1 on paper 2 for Leaving Cert was on probability. And it asked you to explain the following terms. So sample space, mutually exclusive events, independent events. So make sure you go through the chapter and just take the little snippets of definitions that's from them. So sample space, you need a definition written around something like the sample space is the set of all possible outcomes. Okay, and you can give an example which you want, which it could be you roll a dice and the sample space is 1, 2, 3, 4, 5, or 6. Mutually exclusive events then are events that cannot happen at the same time. Okay, so that's events that are mutually exclusive. Okay, they cannot occur together. Okay, independent events then on the other hand are when the outcome of one event does not influence the outcome of the next event. Okay, then we say their outcomes are independent. Okay, or these are independent events. And there's proofs for showing that events are independent. There's a formula for showing that they are mutually exclusive events. So make sure you know them. Okay, so part B then, in a class of 30 students, 20 study physics, 6 study biology, and 4 study both physics and biology. Represent the information on the Venn diagram. Okay, a student selected at random from the class. The events E and F are E, the student studies physics, F, the student studies biology. Okay, so if it were sets, okay, so I'm going to draw another one over here. Okay, so this is physics, this is biology. So in a class of 30 students, 20 study physics, 6 study biology, and 4 study both physics and biology. So I don't know if you remember from sets, you fill from the inside out. So 4 study both physics and biology, 20 study physics, which is here, and 6 study biology, which is 2 over here. Okay, so 16 and 4 is 20, 22. So I have 8 outside that study neither. So in a class of 30 students, 20 study physics. So there's 16 and 4. That gives me my 20 studying physics. That's why that had to be 16, because it all had to add up to 20. These are my 6 that study biology. Again, 4 study both, which means 2 must just study biology only. Okay, it's a class of 30, so I have 16 and 4, 20, and 2 is 22, and the 8 on the outside to bring me up to 30. Okay, so represent the following on the Venn diagram. Okay, a student is selected at random. The events E and F are such that E is the student study physics, and F is the student study biology. By calculating probabilities, investigate if the events E and F are independent. Okay, so how do I do this? How do we test for independent events? Okay, well, independent events are, there's a couple of formulas. The probability of A by the probability of B is equal to the probability of the intersection. Okay, so that's independent events. Okay, now probabilities. Okay, this is why I suppose I did the Venn diagram over here, because that's a traditional Venn diagram rather than a probabilities Venn diagram. Okay, it didn't specify here, so I would love to know which way they wanted it. Okay, so what is the probability that someone is studying physics and biology? Well, let's just change it. So E is studying physics, F is biology. Okay, so physics is E, biology is F. Okay, so the probability that they study physics, I would say, is 20 out of 30. Okay, the probability that they study biology is 6 out of 30. Okay, and that, if they are independent events, is equal to the intersection, which is 4 out of 30. Okay, so let's try that on the calculator. So 4 out of 30 first is 2 over 15. 20 out of 30 by 6 out of 30 is 2 over 15, and that simplifies to 2 over 15. Okay, so these are equal, therefore A and B are independent events. Okay, why did I leave it blank down here? Because I wanted to show you another way of doing it. So instead of just having 16 here, you could have 16 over 30, for example. Okay, now I'm not going to convert them to decimal. I normally would, but I'm not, because I'm getting multiple decimal places. But you have 8 over 15. Okay, let me just zoom in a bit. So that's 8 over 15. Okay, the 4 in the middle breaks down to 2 over 15. We know that one already. And then these two people here is 2 out of 30, which would be 1 over 15. And then the 8 over 30 would break down to 4 over 15. Okay, so you could write it like that, which is the probabilities of them doing them. I don't think it would have mattered in this question which way you went in doing it. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.